got this passion. I want to share it with you. I want to share it with the VCE community. I want to share it with anyone who might be interested in synthesizers. I want to share it with your grandmother. You can give her a call. Give her a call now. Call your grandma and say, look, I want you to watch this YouTube video with Bernie D. It's all about synthesizers. Bernie D, back with you again for the Soundside Academy, an initiative of the Inner West Union of Anarcho-Syndicalist Witch Doctors. Of course, you know by now, I'm an artist, a rapper, a yogi, and an anarcho-syndicalist witch doctor. And today, I want to talk about something that a lot of rappers do, and I am in this category myself, and that is that we also produce the tunes that we rap over. And part of that production activity involves using certain devices known as synthesizers. And today I'm going to be talking to you about the use of those synthesizers, both in the context of music production and in a larger context, which connects with another entity that is connected to the Inner West Union of Anarcho-Syndicalist Witch Doctors, and of which the Soundside Academy is also an affiliate. Now, it can be tricky to triangulate between all of these different entities, but the entity that I'm describing is actually an entity that studies entities. It is the Center for VCE Studies. I think I've got that right. It's the Center for, sorry, I got that wrong. It's the Center for VCE Communications. Always mess that up. The Center for VCE Communications. Now, you may well be asking, what is a VCE? And of course, that is a very good question to be asking at this point. What is a VCE? For those of you who are familiar with synthesizer terminology, the term VCE may sound like it fits within a certain family of terms, the VCA being another one, that is the voltage controlled amplifier. And we'll talk a little bit about VCAs today in today's tutorial content. So we've got that coming up. So we've got the VCA is the voltage controlled amplifier, the VCF, voltage controlled filter, right? Yeah, that's another term that you may be familiar with from the point of view of synthesizer terminology for all of those synth nerds out there. And this is a video that is really going out to the synth nerds. Of course, I encourage others to stick around and enjoy this content also, because there will be some musical content today, and I think we can all appreciate that. And I'm sure even if you haven't quite got into the nerdy side of synthesizers yet, you have no doubt appreciated music that uses the synthesizer as an instrument. I mean, it's pretty hard not to have heard a tune that you like that includes a synthesizer at this point in history. So you've no doubt familiar with some of the sounds that come out of synthesizers. What I suggest is today you can learn a little bit about what's going on behind those sounds, even if you're not a synth nerd, but there will be content for synth nerds today too. So if you're in that category of synth nerds, I certainly count myself in that category, I suggest you stick around. There's going to be some interesting content in that regard. But we do need to talk about the Center for VCE Studies. That's what we're ranting a little bit about here at the beginning, because this is part of that affiliation that the Soundside Academy has with that Center for VCE Studies. And I'm getting to the point. I really am getting to the point. We talked about the VCA, voltage controlled amplifier. We've got the VCF, voltage controlled filter. And we've got the VCO. I guess you can guess what the first two letters of that acronym stand for. Yes, you got it right. Voltage controlled oscillator in this case. So we've got all of these VCs, right? Now we've got the VCEs, and voltage is the first word of that acronym. But also there is a slight tweak here, right? Voltage is the first word. we're talking about voltage controlling with the ing, voltage controlling entities, right? We're talking about the communications of voltage controlling entities. Now, I myself am a voltage controlling entity. That's right. I control voltages on synthesizers. I move them around. I try and find nice patches within their circuitry, right? That's one of the things that I do as a voltage controlling entity. But of course, the voltage controlling entities, plural, there are many of them. The voltage controlling entities are not always human intelligences. And this is really the subject of the Center for VCE Communications, is to study those non-human voltage controlling entities. And these are, well, look, you could call them synth spirits. They're intelligences that are channeled through human agents, right? Intelligences that come through these human agents and allow those human agents to make very precise adjustments to the synthesizer interface in order to happen upon certain sounds that are pleasing to the voltage controlling entities, right? That's what they're there for. They're kind of like our muses, like they're muses for synth nerds. That's one way to think about them. They these entities, synth spirits, that come to us and help guide our actions in operating synthesizers. Now, we do the study of voltage controlling entities as part of this network, the Center for VCE Studies. This is a multi-center network of researchers who are studying VCE communications, and the fundamental activity of the VCE communications researcher is, of course, listening, tuning in to the sounds that synthesizers make. That's what every good researcher does. And you don't actually have to be twisting knobs on a synthesizer to be a VCE researcher. That's, I mean, a lot of us end up doing that because it's a kind of natural thing that you kind of get led towards as a VCE researcher. But you can do very good VCE research simply listening to the recordings of VCEs produced by skilled VCE researcher operators. You can just do that research by listening. You know, that's all you really need to do to be a VCE researcher, is just attune yourself to the communications of voltage controlling entities. That makes you a VCE researcher. And of course, you can do this research too, right? Yes. Everyone can be a VCE researcher. It needs to be said. It needs to be said. At this point, it's a very democratic and open field, and anyone can participate in VCE research. Now, having said that, there is this thing of like being a VCE researcher operator, and that's something that I'm going to talk about today because I've got a patch loaded onto my synthesizer in front of me here. I've got this patch and I want to share it with you. I want to share it with the VCE community. I want to share it with anyone who might be interested in synthesizers. I want to share it with your grandmother. You can give her a call. Give her a call now. Call your grandma and say, look, I want you to watch this YouTube video with Bernie D. It's all about synthesizers and I think you're going to like it. At least you might find him a little bit weird and interesting. And so yeah, call your grandma, call your auntie, call your aunties, all of them, plurals again. Call them all and just say, let's let's watch this YouTube video with Bernie D where he talks about synthesizers. Okay, all right, that's enough of me ranting on. Let's get down to the patch that's in front of me here. I'm going to switch camera views so you can see the synth setup that I have in front of me. Yeah, that's right. Okay, and I do need to do a little bit of explaining what's going on here. This is particularly for the synth nerd. This is the synth nerd section. We will get onto a slightly more musical section in a moment, but this is the synth nerd section. So here we are. We have these pads. These pads are providing MIDI signals that are running into this box here. This is a Pro Solo Mark III by Kenton. It's a company out of the UK, and they make this box, so far as I can see. Like, if you go on YouTube and watch the YouTube videos, they're all about some kind of version of this box, and it's a box that takes MIDI signals like the ones these pads create, takes those MIDI signals and converts them to control voltages, right? We're talking about control voltages, or you know, the VCEs, the voltage controlling entities. Well, this gives us voltages out of MIDI, right? So out of this box, we have voltages that are coming. We have voltages that are controlling the notes of both of these synthesizers. Now, I've got two synthesizers here. This is the Moog Werkstatt 01. It's a analog synthesizer. I have a pair of those. They're really acting as a single synth voice, right? They're acting as a single synth voice. So they're acting as a two oscillator synth voice, right? Is what I would say. That's maybe the most appropriate way to say it. And so I've got signals coming out of the Kenton Pro Solo Mark III into this device here. Now, this is a device that, if I just tilt upwards, you can see inside the circuitry of this device. This is the device that I built with my collaborator, Ben Denham. We spent some time perusing this circuit and acquiring the necessary components to build this particular device. It's a envelope generator, and you can build one too if you so wish. You can go to the Electric Druid website and you can buy that chip right there, that chip inside. You can see that white chip there. You can buy that chip and you can make your own envelope generator if you buy a whole bunch more components as well, and you know how to follow a circuit diagram. So we've got CV running out of this device. We've got MIDI coming in from the pads. We've got CV running out. That CV is running, so I should say CV control voltage. In this case, what is called CV on this box, and you can see if you have very sharp eyes, you might be able to read that says CV there. What is called CV on this box is actually controlling the note. It is the voltage that is controlling the note, and the standard for this is 1 note per octave, and we've got that voltage going 2 places, and in order for it to go 2 places, it's going through this box here, which is a buffered multiplier of the signal, right? Buffered mults, they allow you to take a signal and send it multiple places, and in this case, I've got it going into both of these synthesizers so that I'm sending them the same note values, and you can hear basically I've selected a scale on these pads controllers, and that is and from there those values are being translated into CV, which is going into the VCO, right, to control the oscillator, the node of the oscillator. That's the voltage controlled oscillator, and these voltages coming from the pads are being translated from MIDI to CV, are going into the VCO and controlling the notes, the frequency of the notes. That is what is going out of here. And then, of course, we have a gate. A gate is like the trigger for the envelope, and the gate is going into the envelope generator. That makes sense, right? Because that's where the envelope is coming from. And then out of the envelope generator, we're going again into the buffered malts. So this allows me to send that envelope signal to multiple destinations. And you'll see I'm using all of those malts that are provided here. I've got 1 voltage coming in. This is the input, and then I'm using 4 copies of that voltage going to different places over here. The reason I'm using 4 copies is that one of those copies is going to the VCA, the voltage controlled amplifier, on each of the synthesizers, and that is what you're hearing is really that VCA being controlled by the pads. So that's what you're hearing there. That's the VCA going into the VCA, but I'm also sending a copy of the envelope signal to the gate in on both of these. And now what that does is that it triggers the internal envelope of the Moog Werkstatt. And once I've triggered the internal envelope of the Moog Werkstatt, I can use the VC. I can use the mod capabilities, the modulation capabilities of the Moog Werkstatt, both on the VCF and the VCO. I can use this envelope to control the filter and the oscillator with its own unique envelope. Okay, because it's being triggered by this envelope, but all it's doing is acting as a trigger, and then I can use this attack and decay and sustain in order to dial in an envelope. So if I want to make, so you'll hear in a moment, like if I crank up the decay here, there it is. We hear that note ringing out for longer from this particular synth, and we'll bring it back to more or less where it was, right there. Same over here, crank up the decay. It's more subtle on this side, but you can still hear that note ringing out. But I want to bring it back to where it was. Okay, so that's a lot of what's happening in this patch. Now, the next step of this is that we're going out of the Moog Werkstatt 01 into this distortion pedal. So we've got some distortion happening. So without the distortion. And again with the distortion. So that's coming out of this voice. Coming out of this voice, we're going into this box here, and this is another filter stage. So this is both of these. In fact, this is kind of like a little bit of an ad for Electric Druid, because although I'm not receiving any payment for this from the Electric Druid guy, Tom, hi there. This is kind of an ad for Electric Druid, because this is as I said, this chip is from Electric Druid, build the circuit around that. This distortion pedal also from Electric Druid, a little kit with a nice PCB and the potentiometers, a few other bits and bobs that you can order off the website. This is in a non-standard enclosure. This is also PCB kit off the Electric Druid website. It's called Filter Effects. It's another filter stage, as I said. And what it's doing here is it's giving me some resonance, but unlike the filter on the Moog Werkstatt, when I turn on the resonance on this filter, I don't lose the bass, right? If you turn up the knob on the Moog Werkstatt, let's maybe, let's turn this one up. You can hear we lose a lot of bass, yeah? Yeah, that's just a ladder filter on a Moog instrument, right? You have that bass drop off. Now, this is a different type of filter, and not better, certainly. I mean, the Moog filter is legendary, but this particular kind of filter does not cut out those low frequencies, so I can get resonance at low frequencies here, and that's what I'm doing for this patch. That's what you're hearing. Okay, particularly down low there, you can really hear that nice beefy resonance coming in. If I turn that off, So turn that back on. Chunky resonance provided by the filter effects pedal. I'm then going through a line delay. I don't have it turned on. Maybe we should just turn it on, and see how that sounds like. The line delay, the line 6 delay, I should say, the green one, the famous green one. And here's what it sounds like. If I just do a bit of tweaking here, wake it up so that I can tweak that. And we might just go back to the good old ping pong delay. Create a bit of a stereo effect. Okay, let's bring the delay time way down. In the mix, that's the dry signal. Maybe just a little bit, maybe right there. So that's the delay. Then we're going through a Boss reverb pedal. That's the RV5, the digital reverb, the Boss pedal, which is off screen there. It's just a plate. It's the plate setting with everything set to 12 o'clock. That's the sound that you're hearing there from the Boss reverb, and that's almost the patch. In its entirety. I've almost described to you this patch in its entirety. But there is one other feature of the patch, and that is that the Pro Solo is providing us with further modulation in that it's running in. We've got some velocity values. So you might have noticed that I've got velocity sensitivity, so I can go from this ringing type sound to a more distorted sound as I play harder. Now the reason we're getting that velocity sensitivity is because I'm taking a velocity signal out of the aux2 from the Pro Solo, running that into this envelope generator, and this envelope generator has a level in which allows me to modulate the level of the envelope with, in this case, velocity signals coming from the pads. And then the other element is that there is an LFO in this little box here. It contains an LFO. It also contains an envelope, which I'm not using, but it contains an LFO. And that LFO is giving us some vibrato type effect that you can hear there. It's actually nice vibrato, and what differentiates it a little bit from the LFOs that are running in the Moog Werkstats is that it is the wave is re-triggered every time you play a note. The waveform of the LFO is re-triggered every time you play a note. So instead of these guys, which are just kind of free running, this has been re-triggered by the notes. Basically means that pulsing cycle is always going to start at the same point given any note that I play. Every time I play a note, it will restart that pulsing cycle. Okay, so that's the vibrato that's running. Then I've also got that LFO signal going over into the filter effects, and it's running into a sync input on this pedal, and it's just giving me a little bit of wobble to that filter effect there. Okay, and it's kind of in time with the vibrato that is being provided by the LFO, which is modulating, I should say, the frequency signals, the CV signal. It's being modulated. It's wobbling that frequency up and down to give you that vibrato effect. And so yeah, that's what's going on there. Yeah, and this is what it sounds like. This is okay. Let's just have a bit of a jam on this patch, shall we? So yeah, that's jam. That's jam on the Moog Werkstatt 01 with this particular configuration, this patch that I've described to you today. Check out the Center for VCE Communications. Interesting organization, and also thank you for supporting this channel by watching this video. Bernie D signing off out of this joint. See you next time.